Hello. Today we're going to do 4.2 theoretical probability. We'll define probability, identify the differences between experimental and theoretical probability, and define simple event and complementary event. Note number 1, probability is the likelihood of an event occurring. Experimental probability uses data collected in a simulation or an experiment. So remember, a simulation is when you don't actually use the object you're referring to, like drawing pieces of paper out of a hat. One piece of paper says heads, the other piece of paper says tails, to simulate or replicate the idea of tossing a coin. Experiment is what it is. You're actually using a coin to determine the number of outcomes and the probability of getting a tail on 10 coin flips. Experimental probability is limited since the data size is often small. Theoretical probability is equal to the number of outcomes that make up an event to the, so that's a ratio, number of possible outcomes. That turns into a formula. Okay, where they change the ratio symbol to a division symbol. So the formula is there. Okay? All right. When the event has one possible outcome, then this is called a simple event. Given enough trials, the experimental probability is equal to the theoretical probability. Okay, example 1. I've changed your handout so that it matches something that you can do at home as opposed to something that we would have done in class. Roll a die 10 times, record the frequency of each roll in the chart. Use the chart to answer the following questions. Okay, so if you were to roll a die and the number of rolls that came up a 1 was 3, there were 3 rolls. So frequency is the number of times you roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So if I rolled the die and I had 3 rolls that came up a 1, I would have a frequency of 3 for roll number 1. If I rolled a 2 only once out of my 10 times, okay, I'd have a frequency of 1 and so on, right? So one more time, if I rolled a 3 twice, then my frequency for rolling a 3 would be 2. And because I'm only rolling it 10 times at all of these frequencies, 3 plus 1 is 4, plus 2 is 6, plus 1 is 7, plus 1 is 8, plus 2 is 10. So that equals 10, the number of times you rolled the die. Okay? So what is the experimental probability of rolling a 5? So the experiment is here, right? So this is our experiment. So rolling a 5 was here, so I was only able to roll a 5 once. So the experimental probability, so the probability of getting a 5 is the number of times I got a 5 out of the 10 possible times. Okay? Rolling a 3, it happened twice. So the probability of rolling a 3 was 2 out of 10. We can reduce that to get 1 out of 5. Okay, so the probability of rolling a 3 in my experiment is 1 out of 5. Now, these numbers would change, right, depending on what you actually rolled. what your actual experiment gave you. Rolling a 4 or more. Okay, so there's the 4s. Rolling a 4 or more would be 1 plus 1 plus 2. Okay, so I had 4 outcomes where I would have rolled a 4, a 5, or a 6. So rolling a 4 or more is the probability of greater than 4, okay, is equal to the 1 plus 1 plus 2. 1 plus 1 plus 2 out of 10 equals 4 out of 10. I reduce that, divide both of them by 2. Probability of rolling a 4 or more. And let's do this. Probability of a 4, a 5, or a 6. I think that would be more clear. Rolling less than 4 means I don't roll a 4. I roll something that's less than 4, right? So the probability of rolling a 3, a 2, or a 1, okay, is here. So that's D. So that's 2 plus 1 plus 3. So 2 plus 1 plus 3 out of 10. Add those together, you get a 6 out of 10. So that reduce, divide that by 2, both of those, 3 out of 5. Okay, rolling a number that's greater than 2. Greater than 2 would be these values here, right? Rolling a greater than 2. So it's the 2, the 1, the 1, and the 2. Probability of a greater than 2 is 3, 4, 5, 6. Greater than 2 is the probability of a 3, 4, 5, 6. So 2 plus 1 plus 1 plus 2. 2 plus 1 plus 1 plus 2. So adding those together, you get a 6 out of 10. And dividing them both by 2 to reduce them, 3 out of 5. Rolling a 2 or less. 2 or less are these ones, so that's F. So that's a 1 plus 3. Probability of a 2 or less. So that's 1 plus 3. 1 plus 3 out of 10 is 4 out of 10. Reduce like you normally would a fraction, 2 out of 5. Now the theoretical probability is what would you get if you actually looked at the die, okay? So rolling a 5, probability of rolling a 5, there's only one 5, okay? So there's only one 5. So the theoretical probability is a 1 out of 6, okay? So it's the number of 5s, 5 on a die, divided by the number of possible outcomes. Okay? Rolling a 3, the probability of rolling a 3 is 1 out of 6 because the number of 3s on a die, there's only one of them, right? Divided by the number of possible outcomes. So your die is 6-sided, that's why there's a 6 there. Rolling a 4 or more. So the probability of rolling a 4, a 5, or 6, okay? There's there's 1 4 on the die, there's 1 5 on the die, and there's 1 6 on the die. So that means it's 3 out of 6 because we have 1 4, we have 1 5, and we have 1 6. Okay? So how many do we have? We have 1, 2, 3 outcomes out of the number of possible outcomes. Rolling less than 4 is rolling a 3, a 4, 3, a 2, a 1. Okay. Well, there's 1 3, there's 1 2, and there's 1 1. So in total, it's 3 out of 6 because there's 1 3, there's 1 2, and there's 1 1. So in total, you count them up. Okay. This type of probability is called the counting probabilities, right? Because you're counting the number of outcomes that you're desiring, and what your preference is, you write in the bracket. And then the 6 is the number of possible outcomes. Rolling a number greater than 2. So the probability of rolling a number greater than 2. So it doesn't include the 2, it's greater than 2. So the probability of rolling greater than 2 is rolling a 3, a 4, a 5, and a 6. So there's 1 3, 1 4, 1 5, 1 6. So that's a total of 4 outcomes that would satisfy your requirement of rolling a number greater than 2 out of 6 possible outcomes. So there's 1 3, there's 1 4, there's 1 5, and there's 1 6. All divided by the number of possible outcomes because there's 6 sides on the die. Okay, we should be reducing these. Okay, so 3 out of 6 is equal to 1/2. 3 out of 6 is equal to 1/2. You reduce this, 2 out of 3. Okay, so you're reducing these probability fractions just as you normally would a fraction. Rolling a 2 or less. So the probability of rolling a 2 means you include the 2 or less. You've got only the 2 and the 1. Probability of getting a 2 or a 1. There's 1 2 and there's 1 1. So it's 2 out of 6. So that's the same as there's 1 2 and there's 1 1. And then the 6 is the number of possible outcomes. Okay, so in summary then, we're using a formula for theoretical probability. This has always been a formula, okay? And we refer to the formula way up here. So here's your formula. The probability of event A, that's your desired outcome, is equal to the number of times you're going to get the desired outcome. So when we talk about the number of times, we were counting. Where probability of A is the probability of event A, that's your desired event. Okay, so that's your desired event, that's your goal. It's what you're looking for, okay? The number of A, so the number of times that outcome of A occurs is also called the event space. So the event is special, right? That's why they call it the event space. The number of S, or that's what it is, the number of S, so the number of all possible outcomes is also called the sample space. So you could think of it just simply as sample space could be a cookie jar containing lots of cookies, and all you want are the chocolate chip ones. So because your desired event or your cookie is your chocolate chip, your event space would be all of the chocolate chip cookies, so counting them, 1, 2, 3, 4, 5, and your sample space would be the number of total cookies in the jar, okay? So the probability of you getting a chocolate chip cookie is the number of cookies that are chocolate chip in the numerator, and the number of cookies in total in the jar would be your denominator, and then reduce that like you would a fraction. So in this complementary event, we'll continue to talk about cookies. So a complementary event includes all the events that are not in the sample space. So if you had a jar, okay, and you had cookies, okay, and you only, so the number of cookies, let's say you had, to be simple, we had 20 cookies, okay? So, and again, I'm saying I want chocolate chip because that would be really true for me. Okay, so this notation, this A prime, or the complement of A is really how it's read. So A with this little dash means the complement of A, okay? The formula for the probability of the complementary event is the probability of the complementary event is 1 minus the probability of getting the event that you desire, okay? So the probability of the complement is the probability of complementary event A. So complementary event sorry, I'm back. Okay, so here we were. Okay, so P, the probability of the complementary event is just what I've said, and the probability of event A is this in words. Okay, so let's identify what we're talking about. So if I said that there were 5 chocolate chip cookies and there were 15 other types of cookies, okay? So if I said the probability of getting a chocolate chip cookie, okay, would be 5 out of 20, right? So if I wrote the probability of the complement, okay, that's the complement, it's what is not chocolate chip, okay? So it's equal to the probability of not chocolate chip. Well, that's the probability of all my cookies, okay, minus getting chocolate chip. And you subtract just like you normally would in a fraction. Okay, so the probability of not getting chocolate chip, not getting chocolate chip is equal to 15 out of 20. Now, you might say, well, I already knew that because you told me that. And it's true. Okay, you already did know that. But when the numbers are a little different, maybe a little bit bigger, a little larger, you can't count up these two amounts, okay? When you can't do that and it's like an indirect method, then you have to use the subtraction method, okay? It's easier, believe me. Okay, so then you just reduce. So you divide those both by 5. So 3 out of 4, right? Okay. So example 2. In a standard deck of playing cards, I'm going to pause here and come back.